Simultaneous equations. There are a number of ways of solving simultaneous equations. You could, of course, draw a graph and see where the two graphs cross one another. That's okay, but it's not very accurate if we have anything that's not nice whole numbers. So when we end up with decimals and fractions, it all gets a bit messy drawing graphs. First up, though, we're going to think about solving them by elimination. So here are two equations. 2x plus 3y is equal to 8. 3x minus y is equal to 23. We number them 1 and 2, so we know which equation is which. And then if we want to eliminate, we have to have something that's the same in both. We need a coefficient that is the same. So if we times the second equation by 3, then we have 9x minus 3y is 69. Now there's a 3y in equation 1 and a 3y in equation 2. So the elimination method is trying to make one of the variables have the same coefficient in both equations, so then we can eliminate them. How do we eliminate them? We add them together. And if you add them together, you end up with 11x equals 77. 2x plus 9x is 11x. 3y add minus 3y is nothing. And 8 plus 69 is 77. So x is 7. We then substitute that into the second equation to work out that y is minus 2. So elimination works by making a coefficient the same of one of the variables, so you can then eliminate it by either adding or subtracting the equations. As a general rule, if what you're cancelling have different signs, add them. If they're for the same sign, then subtract. 4x minus 5y is 4, 6x plus 2y is 25. Number the equations and think to yourself, how can you make one of the coefficients the same? You've got 4x and 6x, 5y and 2y. There's a few things we could do. However, if we times the top equation by 3, we end up with 12x minus 15y equals 12. And if we times the bottom equation by 2, we end up with 12x plus 4y is 50. We could have done that differently. We could have times the top one by 2 and the bottom one by 5, and that would have made the y coefficients the same. Now we think, are we going to add these or take them away? Well, it's 12x and 12x, so the signs are the same, so we subtract. Minus 15 minus 4 is minus 19, 12 minus 50 is minus 38, so y is 2, and then substitute it into one of the equations, it doesn't matter which one, to find out that x is 3.5. Another method we can use to solve simultaneous equations is substitution. This involves using one equation to write y in terms of x, or maybe x in terms of y, and then substitute it into the other equation. So let's say we have 2x minus y is equal to 1 and 4x plus 2y is minus 30. Number the equations again so we know which one is which. If we rearrange equation 1, we can get y is equal to 2x minus 1. We can then substitute that into the second equation. Just instead of where it says y, write 2x minus 1. So instead of 4x plus 2y, instead have 4x plus 2 lots of 2x minus 1 is equal to minus 30. Then we can expand the bracket out, collect up any like terms, rearrange, and get x is 3.5. Once we have x is 3.5, we then substitute it back in to either equation again, makes no difference, to get that y is minus 8. This is a particularly good method if you have a x, y, y with a coefficient of 1, so you can rearrange it very, very easily. You will need to use the substitution method specifically when one of the equations is quadratic. And with quadratic ones, you may end up with either no answers, one answer, or two answers. So either no, one, or two pairs of answers. So let's consider this here. X plus 2y is 3, and x squared plus 3xy is equal to 10. We can rearrange the first equation to get x is 3y minus 2. We can then substitute that into the second equation. So instead of x squared, we would have 3x minus 2 squared plus 3 lots of 3 minus 2y times y. So 3 minus 2y squared plus 3y, 3 minus 2y is equal to 10. Expand all of the brackets. So 3 minus 2y squared is 3 minus 2y times 3 minus 2y. 9 minus 12y plus 4y squared times it, the linear bracket as well. Collect up any like terms. Minus 2y squared minus 3y minus 1 is equal to 0. Have a little think about the best way to solve that. If we times it by minus 1, we make it look nicer. There's a lot of minus signs floating around. No one likes them. But now we get 2y squared plus 3y plus 1. Then we think to ourselves, well, that factorise, wait, it looks good for it. So we have a 2y and a y at the start, two numbers at times to be 1. There's not many candidates for that, a 1 and a 1. So 2y plus 1 and times y plus 1 is equal to 0. And then we can solve that to give us, that means that either y is equal to minus a half or y is equal to minus 1. Now for each of those values, we now have to work out the corresponding y value. So when y is minus a half, sorry, I should have said corresponding x value. When y is minus a half, we substitute that in to get that x must be 4. And when y is minus 1, we substitute that in to get that x must be 5. So we have two pairs of answers for the quadratic simultaneous equations. Here's another example. 3x minus 2y is equal to 1. X squared plus y squared is equal to 25, the equation of a circle. So this is looking at where a straight line crosses a circle. Rearrange the first one. Y is 3x minus 1 all over 2. You could of course rearrange it to get y if you want, x equals if you wanted to. Substitute that y into equation 2. So instead of y squared, we have 3x minus 1 over 2 squared. Then square the top and the bottom separately. So 9x squared minus 6x plus 1 all over 4. Multiply it out by 4 to get rid of the denominator. Collect up any like terms. Think to yourself, is that likely to factorise? Well, it does. 13x plus 33, x minus 3. Although I would forgive you for another method of trying to solve that quadratic. And then solve it. So x is either minus 33 over 13 or x is equal to 3. And then for each of those x values, substitute them back in to find the corresponding y value. So when we put minus 33 over 13 in, we end up with minus 112 over 26, or minus 56 over 13. And when we substitute 3 in, we end up with y is equal to 4. So again, two pairs of answers.